everyone and welcome back to Switzerland. Today I took the cable car from Zermatt all the way to the Klein Matterhorn lift station that you can see over there. And this is Europe's highest cable car station, located at an elevation of 3,883 meters. From here you can visit and ski on the Matterhorn Glacier Paradise. The reason why I traveled all the way to this elevation is because these mountains are so high that the snow never melts away. Even in the summer, the temperatures are low enough for snow to be preserved. And at such high elevations, where the snow remains year-round, glaciers can form. And what is so cool about this lift station as well is that they built an elevator so you can descend into the glacier and can look in more detail to the glacial ice. So in this video we're gonna explore in more detail how glaciers are formed, and I'm gonna show you some hidden secrets in the glacial ice. Are you ready to explore? So glaciers are huge rivers of ice, and they form from the accumulation of a lot of snow over many years. And in order for glaciers to form, it's crucial that most of the snow is preserved, and thus the glaciers can only form at very high elevations above the snow line. And the snow line is a term that we use for the elevation above which the snow is preserved year-round, so even in the summer. Glaciers, however, are composed of ice and not of snow. So how do we turn a lot of layers of fluffy snow into huge blocks of ice? Let me explain that to you. When you have a fresh layer of snow, about 90% of the volume is open space that is filled with air. And that is because the snowflakes have very large open crystal structures. But look what happened when I compact the snow. I can push some of that air out and I can make the snow denser and denser. As the layers and layers of snow pile upon each other, the weight at the lower snow layers increases. The extremities of the snowflakes are pressed into each other and they start to evaporate. And the water vapor condenses again near the center of the crystal. By this process, most of the air is slowly pushed out, and the snowflakes get smaller and smaller and denser and denser. If the compaction of snow continues long enough, eventually all the snowflakes became so small and so dense that most of the pore space has disappeared. And when the thickness of the layers of snow is approximately 50 meters, at the very base the pressure is so high that the snow has turned into interlocking ice crystals. And that is what we call glacial ice. So glaciers are formed by the accumulation, compaction and recrystallization of snow. I have just descended with the elevator from the Klein Matterhorn lift station into the glacier, and now we can take a closer look to the glacial ice. If you look carefully, you can see the distinct layers in the glacial ice. Isn't it amazing to think that these are the snow layers that were slowly compacted into ice? Think about these layers as tree rings, because each layer represents the annual growth of the glacier. Here in the Alps, some glaciers have hundreds of years of snowfall stored in them. You can find the oldest layers at the bottom and the youngest layers higher at the top. When you are a trained glaciologist, the glacial ice can reveal you all sorts of secrets. If you spend some time looking around, you can see brownish layers in the glacial ice. Most of them are fine layers of dust and sand that originated from the Sahara Desert. During certain weather conditions, wind blows fine dust from northern Africa all the way to the Alps, and this dust is then deposited on top of the snow. And over time, the dust and sand are compacted with the snow and slowly locked up in the glacial ice. If we analyze the glacial ice in even more detail, you find even more hidden treasures. You may find layers of fine volcanic ash, indicating a large volcano erupted somewhere. In addition, Not all air was pushed out during the compaction of the snow. Some air bubbles are still trapped inside the ice. We can measure the concentration of gases, including greenhouse gases, in these bubbles. For example, by measuring the CO2 in the glacial ice that is hundreds and even thousands of years old, scientists unraveled the past CO2 concentrations in our atmosphere. They discovered that the CO2 concentrations were very low during the past ice ages, and that there is thus a strong correlation between the past CO2 concentrations in the atmosphere and the past global temperatures. I hope you enjoyed learning more about glaciers. Next time when you see a glacier from nearby, check out the layers in the ice, and maybe you can also see a layer of the Sahara dust. Thank you very much for watching, and please don't forget to check out my YouTube channel or website if you want to learn more about glaciers. I hope to see you next time. Bye!